Objective 4, construct and interpret stem plots or stem and leaf plot. A stem plot or a stem and leaf plot breaks up each data value into two parts, the leaf and the stem. The leaf is the rightmost, which is only one digit, and the stem is the other digits. So for example, for the following sets of data, determine the stem and leaf for each data value. So for 56, we can see that 5 represents the stem and 6 is the leaf. For 38, 3 is the stem, 8 is the leaf. 29, 2 is the stem, 9 is the leaf. For 10, 1 is the stem, 0 is the leaf. And for 132, we would say that 13 represents the stem, and then 2 is the leaf. Let's take a look at part B. We have 18, 7, 87, and 0. So we're starting out with two digits. So in this case, 1 represents the stem and 8 represents the leaf. For 7, this would be 0, 7. So the stem is 0 and 7 is the leaf. For 87, 8 is the stem, 7 is the leaf. And for 0, we would have double 0, so the stem is 0 and the leaf is 0. For part C, we have 13, 0.4, 3.8, and 9. So we have decimals going to the 10th place. So for 13, we're going to write that as 13.0. 13 represents the stem, 0 represents the leaf. For 0.4, we have 0, 0.4. So the two zeros are the stem, 4 is the leaf. For 3.8, it would be 0, 3.8. So 0, 3 is the stem, 8 is the leaf. And for 0, 9.0, 0, 9 is the stem, and 0 is the leaf. Even though this is considered a 9, we want to make sure that it represents the same in each numbers. Okay, now for example, the following data are gas mileages in miles per gallon of some randomly selected Dodge car models. So let's just go back to what we just did earlier. They're all listed as two-digit numbers, so that's good. And in that scenario, we have 2, 3. So 2 represents the stem, 3 is the leaf. 4 is the stem, 1 is the leaf. So we can create a legend. A legend means that 2 represents the stem and 3 is the leaf, so we write 2, 3. So for gas mileages of Dodge cars, let's take a look at this. So we have how many 23s here? We have 1, we have 2, and then we have 3. So we have a 2 with a stem of 3. We have a 2 with another stem of 3, and we have 2 with the third stem of 3. So that eliminates the 23s. Okay, the next number is 24. How many 24s do we have? We have 1 here and there. So now we have a 2, and then we have a 4, and then a 4 because there's 2 of them. Then we have 25. How many 25s do we have? We have 1, 2, 3, 4, 5. So we should have 5. So we have 2, and then a 5, 5, 5, 5, and 5. And do we have a 26? Well, we have 1 of them. So we have a 6 here. And then do we have a 27? We have 1, 2, 3, 4, 5. So then there's 5 7s. And then we do not have a 28 in here, but we do have a 29. And we have 1 of them, so there's our 9. So now we're done with the 20s. Now we're going to go to the 30s. So do we have a 30? We do. We have 1 of them. So 3 is the stem, 0 is the leaf. And do we have a 31? We have 1, 2, 3, 4. So that means we have 4 1s here to represent 31 4 times. We do not have a 32. Do we have 33s? Well, we have 1 33, so we have a leaf of 1, 3. We have a 34 and only 1 of those. So we have a stem of 3 and 4 as the leaf. We also have a 35. So again, the stem is 3 and the leaf is 5. And then we have a 36 with the stem being 3 and 6 being a leaf. And there are no more 30s. Now we can look at the 40s. So we have a 40 in one of them. So the stem is 4 and the leaf is 0. And then the last number is 41. And so therefore we have a stem of 4 and a leaf of 1. Now we can answer our questions according to our stem plot. Now, what is the frequency of the observation 27 miles per gallon? What does it mean in this situation? So the frequency means is, okay, can we see how many there are of the 27s? So there's 2, and we have 1, 2, 3, 4, and then 5. So the frequency are 5. So there are 5 Dodge cars with a gas mileage of 27 miles per gallon. In part C, the dart arrow gets the best gas mileage of all the cars in the sample. And what is its gas mileage? Well, we know that that is the last one here, and that's represented at 41 miles per gallon. In part D, it says, use the 50th percentile to measure the center of the distribution. Now, the 5th percentile splits the data in half. Okay, so what we want to do is we're going to take our, how many data values do we have? We have a total of 28, and then we divide that by 2. So the total data values that we have is 28. And that's from counting up here. We have 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7. If we multiply 7 times 4, that tells us we have 28 data values. And we want to find the 50th percentile. So in order to find the 50th percentile, we have to divide this number by 2. So 28 divided by 2 is equal to 14. And so now we're going to count 14 in the stem and leaf plot to find out where the 50th percentile is according to this distribution. So up here, we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is part D below. So this 7 represents the 50th percentile. But that 7 is the leaf with the stem of 2. So that tells us that 27 miles per gallon represents the 50th percentile of this distribution.